Hi everyone, welcome back to the session 5 of the MLOps basics. Till now we have conducted four sessions, two for 2 weeks. First week was MLOps basics setup in the week 0, where we discussed how we are going to create the data loader, create the model, train the model, and then run the particular model that we had on inference. In the second session, in the second week, we discussed about model monitoring, which is a big part of the whole ML lifecycle, MLOps lifecycle. So in the current session, we are going to discuss about the configurations and using configurations using Hydra. So exactly before we start, why do we need configurations? For example, when you're working on your own project, configurations are not that important. However, configuration management becomes very important when we are managing complex software systems. And lack of configuration management can cause serious problems with like reliability, uptime, and the ability to scale a system. And one of the things which I realized was very important when you want to scale up a system, it's not like every time we can make so many changes to configuration and then run haphazardly. If you want to run things in a scalable manner, we use configurations. And in this, for configurations, there can be multiple ways. However, in our case, we will be using the example of the Hydra. So, for example, a lot of people do these things using command line arguments, argument parser, config parser, data classes. But here we'll be covering the Hydra part. And in this particular week, we'll be discussing about following things from Hydra. The first is the basics of Hydra, then overriding configurations, splitting configuration across multiple files, then variable interpolation, and then how to run the model with different parameter combinations. We'll see how much we can cover in this session. Rest we will be covering in the next session that we'll have. So basics of Hydra. So first and foremost thing is we need to install Hydra, and Hydra operates on top of Omega configuration, which is YAML-based hierarchical configuration system. I hope everyone of us know about YAML, right? And on Hydra operates on top of Omega configuration, and with support for merging configuration from multiple sources like files, CLI argument, or environment variables, and provide a consistent API regardless of how configuration was created. It's kind of like a making your configuration multi-platform, and in some sense like helping you standardize the process of configuration management. For example, let's look at a very basic YML and import it, where we have preferences, the user Raviraj trait I like my sleeping, and let's load the same file using the Omega configuration, and in this we loaded the config YML, and now we print out the user and the trait they like. So for example, we are using the same, we want to do the same thing using the Hydra. So what we will do, Hydra Omega configuration, and then in Hydra we will try to override this config name basic YML, and in this basic YML we first define the main function in which first we do omega to YML config and print config preferences users that should run Raviraj. If we run the main function, then it will give preferences such as Raviraja, I like my bed, and then Raviraj. So in this, what we did particularly is like we did omega configuration to YAML. We converted this into a YAML and then made a Hydra wrapper on top of it. Now config can also be loaded using without using the Hydra main decorator in the following way. From Hydra we do initialize and compose. In the initialize we initialize that our files are in the current folder with this thing, and then we do config equals to compose and then provide the config name with the initialization path, and then we print the. So if you will print, so it's going to print the preferences user Raviraja trait I like my bed. And now one thing is like we have seen how we can load configurations using Omega configuration or Hydra. Now let's see how we can override those particular configurations. In this particularly, if you are using Python in that the earlier function, the earlier main script that we have written. So in that, if I change the preferences trait equals to I like stars, it prints the preferences users of Viraja and trait I like stars. And this is like overriding this thing simply during the runtime. And now if you want to convert the existing code that we have into Hydra YAML, so let's see how we can do. So the folder structure, we have made something like configs, and config contain config.yml. So if you are building bigger models in the sense of the whole pipeline, it's a very good practice to have everything in a structured way. And for the structured for configs, we generally define in this everything in such in this particular way, where we make a configs directory and there we put config by the different proper config names. So the contents of config of YML generally it contains these details, and these are the details which we use uh, for the models in the earlier sessions, in which the name is this is the model name that we use from Hugging Face, and then this was the tokenizer. And then for processing, we were using the batch size and maximum length of 128 tokens, batch size of 64. And then for the training, we were doing max epochs 1 log and log after every 10 steps, deterministic. Now limit train batch 25%, validation batch 25%. And then now we are loading, let's load the file in train.py code. And then, so now what we are trying to do is we have some YML, config.yml for our particular model. And so, for example, if you want to scale these things, we can create different YMLs for different models, different configurations for different models, and load whichever we want at the runtime or whatever time we want to run it. So, for example, if I want to load this particular configuration into my model, this is what I'll be doing. So this is my train.py. Here I am using the decorator of Hydra main. In this config path is that config directory, and in that particularly I'll be using the config.yml. So in this, when we are running the main function, in that we are seeing like a cola data is like a, so in this from config we are taking the model tokenizer, model config processing batch size and maximum length, and then we are using the data module to have the data ready, the cola data, and for model we are using similarly the model name that we are using. Now for, if you remember, what we were doing earlier is we were having a checkpoint callback, and then in that particularly now we are taking I think these are not none of these are taken from the above config that we have written, but these are like we are telling the model is in our directory, the file name is this check, we are taking the model from this checkpoint, and then we monitor using the valid slash loss, and more equals to minimum of that loss. And then now here you're using the weights and biases logger. In that we are seeing like project MLOps basics and entity is Raviraj. So now we are running the training, and in training also, if you can see, we are particularly taking parameters from the config file that we have defined earlier, the max epochs. Then in callbacks, I think checkpoint callback where we defined. So this is what we defined earlier. And then here we log in every steps, deterministic, limit, train batches, and everything we have taken from the configuration we just defined earlier. So in case if I want to just change the model with any other model, I just change the config file here and a couple of places more, and I think like I'll be done. Like I can use the same code for my different models. So now I hope you can see the beauty in this thing is how we can use this particular configurations, the Hydra, for scaling the same code across different models. Instead of writing the whole code again, it's like so much usable, so much usable. And when you are creating much bigger applications, it's not like you can go and write code for each and everything. You write a lot of code that is reproducible and can be used further. So, so maybe we'll discuss these things in the in the upcoming session. I think this session has already been quite a long, and let's connect in the next session. Thank you for joining.